Hi, in the last video we discussed about how to find out the average or the mean of raw data and a grouped data, and also we talk about how to find median, which is the value that is in the middle of the whole data set, right? When after it is sorting in increasing or decreasing order. So there are two cases. If the number of data are odd, then the value exactly in the middle is the median, right? If the number of data points is even, then there will be two values in the middle, so you need to find out the average of those two values. That's what we discussed last time. Okay, so now what we are going to talk is we want to talk about how to find the mode and the mid-range. Okay, so what is the mode? Mode is the value that is repeated most. That is called the mode. Okay, the value that is repeated most is called the mode. And in case of the frequency distribution table, a class with highest frequency is called the modal class. Okay, a class with highest frequency is called the modal class. For example, if you look at one example from this data, see, so here the data is group data, right? So which class has the highest frequency? This class has the highest frequency, right? Because the frequency is 12 here. So this is the modal class. Okay, that's what it means. So in case of the raw data, you look at the data which is repeated most, and in case of the group data, the mode is the modal class is the class that has the highest frequency. All right. So the next thing we want to do is the mid-range, is the average of the highest and the lowest value. So we find out the highest value, and then you do plus lowest value divided by 2. That is the average of highest and lowest value. Okay. Let us see some examples. Find the mode. This is the raw data, right? So in this data, which value is most repeated? It sounds like 10, 10, 10 is repeated 3 times, right? So the other values are not repeated 3 times or more. That's why the mode is 10. Find the mode of this. Which value is most repeated? It sounds like all of the values are repeated only once, meaning they are not repeated at all. So there is no mode. All right. Find the mid-range. How do I find the mid-range? So find out the lowest value. What is the smallest value? Smallest value sounds like 10, right? And what is the biggest value? Biggest value sounds like 34.5. Smallest value sounds like 10, right? So 34.5 plus 10 divided by 2. So meaning the average of the highest and lowest, that will be 44.5 over 2. That will be 22.25. This is how we find out the mid-range. Okay, some data, that's the node, some data have 2 values repeated maximum number of times. Such data is called the bimodal, meaning if 2 numbers are repeated equal highest number of times, then that is called the bimodal. All right, so the next is the weighted mean. It is similar to the mean of the group data, but you will see the weights. Okay, sometimes we assign more weight to some data points and less to the others. In this case, we compute weighted mean. It is defined by x bar subscript w equals to w1 x1 plus w2 x2 and so on, divided by w1 plus w2 plus ... and then so on. Okay, so to compute the weighted mean, we need 3 columns. We will have x and w given by the question. The next thing we'll have to do is x times w. Okay, so there is one thing that you should be very careful when you find out the weighted mean. That thing is which one is x and which one is w. If x and w are specified by the question, then that will be x and w, but sometimes it will not be given. So you will have to figure out which one is x, which one is w. Okay, so the idea is this. You should look the wording of the question. For example, if you want to find the weighted mean of the grade, if it says find the weighted mean of the grade, then that grade must be x. Okay, then x represent the grade. If you want to find the weighted mean of the cost, it says find the weighted mean of the cost. In that case, x will be the cost, then the other column will be the weights. Okay, other column will be the weights. Look at this. Find the weighted mean grade. So it says weighted mean grade on this table. So the grade must be x, right? And the other column must be w. All right. So how do I do that? Is to find out the weighted mean of the grade, we have the weights and the grade. So you find out w times x. W times x will be 3 times 4 is 12. 3 times 2 is 6. 4 times 3 is 12, and 2 times 1 is 2. You add all of them. How much? 12 plus 12 is 24 plus 6 is 30 plus 2 is 32. So the x bar is the sum of that is 32 divided by how many, what is the total weight? 3 plus 3 is 6 plus 4 is 10 plus 2 is 12. You will get 2.7. What did we do here is you multiply this with that, 3 times 4 plus 3 times 2 plus 4 times 3 plus 2 times 1 divided by sum of the w's, that is 3 plus 3 plus 4 plus 2. That's what you get. That is the weighted mean of the grade. Let us look at another example. In the elementary statistics, the grade distribution are as follows. Quizzes is 12%, online homework is 20%, 4 tests are 12% each, and final exam is 20%. If you scored 89 in quizzes, 84 in homework, 75, 95, 80 and 86 in 4 tests, and 86 in the final, find the weighted average score in this class. So which one is the x then? X is the average, the weighted average of score, that is x. That's why score is x. So score is x, the another is w, that percentage is w. I'm writing the percentage in terms of the decimal, so 0.12, 0.20 and so on for each of those. Okay, now we find out x times w. What is the sum of x times w is 87, sum of the w is 1, so the weighted mean x bar w is 87 divided by 1, because it is summation x times w divided by summation w. If you do that, you get 87. That's what you get. Okay. Alright, that's how you find out the weighted mean. So what is the difference between mean, median and mode? Let's talk about briefly about that, and then we will talk about how to find the variation of the data. Okay. So the mean uses all data points, other do not. What does that mean? That means if you want to find out the mean of a data, you need to add all those data divided by the number of data. So it means the mean uses all the data. Median does not use all the data. Mode does not use all the data, because median only find out the middle value only, and mode find out only the number that is repeated most. And mean is more useful to compute the other measures in statistics than median and mode. The mean and mid-range are affected by the extreme high or low values. For example, if there is a very big value, the mean will be affected by that, because when you add them, then the sum will be big, right? But if you are finding the mode or the median, it is not affected by the big or small value. Why? Because it cares only the middle value. All right. So that's what the third point is. The fourth is mode is easier to compute, because you can just look at the question and then see which one is most repeated. That is the mode, and can be used in qualitative data too. In the qualitative data, you cannot find out mean and median, right? Because the mode is final. Because for example, if you want to know how many students like a particular color in a class, you can find out the mode, meaning which color is most repeated is the mode color. Okay, but you cannot find out the median and mode directly that way. Okay, mode may not be unique, but mean and median are unique. What does that mean? That means there may be more than one mode, because there may be more than one value repeated maximum number of times, right? But the mean and median are only one. All right, shape of the distribution. So you can decide without drawing the graph of a function of a data points. You can decide whether the data is right skewed or left skewed or symmetric. Okay. So what is the idea? If mean, median and mode of a data are equal, we call symmetric or normal or bell shaped. This is what it is. That middle line is mean, median and mode value. Now, if mean is bigger than median is always in the middle. Okay. If mean is bigger than median and median is bigger than mode, meaning if the height of the bar on the left is taller and the mean is bigger, in that case mean is the bigger. If mean is the biggest one, then we call positively skewed. If mean is the smallest one, we call negatively skewed. Why did I say smallest? Because see, it may be 1, 2, 3, 4, 5 is the mean, 6 is the median, 7 is the mode, kind of. Okay, so mean is the smallest one, that is left skewed. Mean is the biggest one, that is right skewed. That's what we say. All right, that is the distribution, the identification of the distribution by the mean, median and mode. The next thing we want to find is section 3.2, which is the measure of variation. Okay, what is meaning of measure of variation? So we want to know which data is most scattered from the mean or the median, so from the central values. Okay, so two different data set may have the same central value. The center value do not say anything about how much the data are scattered. The measure of spread of variability of data, to measure the spread of scatteredness or the variability of the data, we use a range, variance, or standard deviation. We also use quartiles too, okay, later. All right, quartiles, percentile, all those kind of things. Okay, so the range is the difference between the highest data and the lowest data. So you find out the highest data and then the smallest data, and you find the difference. So if the difference is big, then you can say the data are very scattered. If the difference is small, then we say that data are not very scattered. So calculate the range. So what is the highest data point here? So the highest is 17. And what is the lowest? Lowest is 5. So what is the range? The range is highest minus lowest, right? That will be 17 minus 5, that is 12. So the range is 12. But if you have another set of data, and then if you say which data is more scattered, if you want to find out that, then you can just find out the range of that data and then see which range is bigger. Bigger range means more scattered. Smaller range means less scattered. Okay guys, so let me stop here for now. In the next video I will show you how to find out the standard deviation or the variance. Okay guys, thank you.